Hi, folks. My name is Cian Clarke from Nearform, and today I'm going to be talking to you about moving from 1x productivity to 10x, embarking on the AI native engineering journey. Along the way, we're going to cover elements of vibe coding, spec driven development, and also how to orchestrate multiple agents. Today, we're going to talk a little bit about the maturity journey that people go on when developing AI native methodologies within their organization. We're going to talk about what the landscape of tools looks like. We're going to talk a little bit about unicorns along the way, but not billion-dollar SaaS startups, actual unicorn, horse-like characters with horns coming out of their heads, genuine unicorns, just as a way to kind of showcase with a little bit of fun how the different frontiers manifest themselves. We're going to talk about what are the three frontiers that we've seen over the last year, starting with vibe coding, spec-driven development, and then into agent orchestration. We're going to talk a little bit about the impacts beyond engineering into how to engineer products for this new world. We're going to present very briefly a reference architecture, and then some resources as well to take things further. If we look at how the maturity journey manifests itself, we think of these four stages. And so most teams start with AI assisted coding, right? So co-pilots for auto-completing function snippets, but not really changing their broader workflow. And so they're using the chat in the right-hand side of their IDE to frame questions. They're writing line by line, maybe possibly, extended out to functions, but they're not transforming entire repositories. And so the kind of trust profile of this method of interaction with a model is quite limited. They tend to review everything before they run the code, and it's still very much humans writing the code. The kind of productivity gains to be seen here, maybe 1.1x. Actually, some studies showing productivity goes down. So, let's say 0.8x productivity. But as they start to move up in their maturity journey, they start to AI augment broader workflows. And so, what this usually looks like is using agent mode within their IDE to ship changes across multiple files. And so they're increasingly using that sidebar chat. It's probably grown in size a little bit in the IDE to maybe a 50-50 split, code on the left, chat on the right. The trust profile is also growing. And so you might enable automatic permissions for all commands within the given repository for that agent, for that coding agent within something like Cursor or VS Code with Copilot. But really, it's still humans steering the agent through kind of a series of smaller one-shot prompts, and still very much humans reviewing the output. That does lead to some pretty substantial gains in productivity, but it has a hard ceiling that we'll talk about in a little bit. Then, as folk move to stage 3 in the maturity journey, we see them start to use much better context engineering techniques like spec-driven development to be able to hone the outputs of the model. So developers write specs, agents are generating the code, generating the tests, and often, they're transitioning from using an IDE either to having like a full screen chat window within their IDE or just jumping to a command line tool like a Claude Code or a Codex CLI or a Copilot CLI. So they're transitioning out of the IDE into these sort of first class citizen harnesses that live in the command line. The trust profile also grows quite a bit, and the pace of development makes it such that reviewing everything becomes increasingly unfeasible. So lots of guardrails are needed in place at this stage to be able to ship much broader snippets or much broader sections of code without review of every single line. What's really important at this point is to start testing completeness and testing the intent of the specs is indeed fulfilled rather than every single line, and you can still rely on static analysis tooling to make up the delta of that review. Then when we get to this sort of future horizon of orchestrating agents at scale, you wind up with multiple agent teams, along with multiple human drivers of those teams of agents, all able to ship and work in parallel. And so at this point, you're really looking at pretty substantial productivity gains, and what would have taken, weeks or months with standard software development methodologies with spec driven can take a week or so. When you move into this world of parallel agents, you're talking a day's work to ship a software system. So truly the next frontier. But with that, a much greater trust profile. And so, the degree of guardrails and tests needed to be able to ship at this scale can't be understated. It's truly unfeasible to review line by line. So it, really does feel like a future frontier. Most folk are not necessarily ready for this kind of, multiple agents being orchestrated in parallel, the pace with which that produces code. But nonetheless, one to really keep an eye on within the enterprise because it is that next frontier that's coming down the line. So with so much happening over the last kind of 12 months, what's led to such a kind of a rapid evolution in the techniques that we use? Copilot's been around since 2022. And then you look at vibe coding, the term coined by Andrej Karpathy back in February 2025. Like that's only a year ago, a little over a year ago. We just passed the 1 year anniversary of vibe coding. But it's really been the last kind of year and a half that we've seen such a rapid acceleration with, Amazon's Kiro being the first IDE to codify some of these spec-driven concepts within the IDE, Cursor's 2.0 release, and then most recently, some really notable releases in the space of agent orchestration, that next frontier, with Gastown being released, the open source project, and then later also Claude Code Teams being released. Very important release from the Claude Code team, which allows multiple teams of Claude Code agents to work in parallel. And so, if we look at the landscape of tools that's kind of established, we can see, a kind of a natural starting point for most folk. At the absolute kind of cutting edge of the maturity curve is Claude Code, which, is really the kind of best as of March 2026, the best sort of AI coding harness on the market, but needs quite a bit of maturity to operate. It works best in the command line. The user interface is quite basic, and so needs a good degree of maturity to utilize. Whereas if we look at something like Kiro as an IDE, it's very easy to get started with spec-driven development within an IDE that codifies it as a first-class principle. Cursor, again, very easy to get started with, very user-friendly user experience, lots of recent innovations like plan mode, and lots of nice design features to be able to better visualize the work that it's doing. Google with anti-gravity also, well worth checking out. And then also, the spec-driven development frameworks that help context engineer your web to a solution, with two kind of key callouts here. One being the BMAD method that we've had great success with, and then also OpenSpec, a lighter weight framework that as you get more mature in your kind of context engineering can yield better results. BMAD being a little bit more rigid and opinionated, but gives you a very safe guardrails or workflow to work through a spec-driven project. Great starting point. If we look at stage 2 then in the world of vibe coding, traditional vibe coding flow tends to have some challenges, right? So if we use a one-shot prompt and a single context window, it tends to yield far less effective results over time than were we to, properly specify all of the information needed up front. And so what tends to happen is a user will come along and say, hey, I'd like to build a blah, blah, blah. And then, the model goes away and does some work, and they realize they've actually forgotten a requirement along the way. They let the model know, it does some rework. Then they realize, actually, the model's built this with React, and my team knows Angular really well. Can you rebuild this with Angular? So then the model does some more rework. Then the user realizes, oh, actually, you forgot one of my requirements. And then the model gets stuck, decides to retool. AI models love retooling when they get stuck. So they'll swap out a test runner, swap out a HTTP framework from Fastify to Express. Some sort of arbitrary retooling will happen. Then you realize actually the model along the way added a feature that we didn't want at all. And then you run out of tokens and compaction happens and the whole thing starts over again. So the kind of approach of one-shotting a prompt and then tweaking in the chat has a certain kind of limitation of scale along the way. To showcase this, I'm actually going to switch to my IDE now, and we're going to do a little vibe coding. So we're going to ask the AI model to build a 3D rendering engine to render unicorns in varying configurations in the browser. So we're going to ask it to go and render some unicorns, and we're going to check in on progress with this in a little bit. And in the meantime, we're going to continue with the presentation. This is an example of a previous badly completed vibe-coded unicorn rendering engine. It looks more like a rhinoceros. But, the beauty of non-deterministic models generating outputs is the demo gods are even more severe because you never quite know what you're going to get as output at the end of all this. It makes it all very exciting. And so hopefully our model has now finished, and I'm going to try and present some unicorn-ridden results. Okay. So here is our vibe coded unicorn from the model. And as you can see, not the best. It looks more like a sausage dog than a unicorn, not the most compelling. So, how do we solve for this? The world of spec driven development solves for this sort of under specification problem by being a little bit more explicit in what it is that we want to build. And so much like engineers, it turns out that AI performs far better when we actually break down a problem and talk about why we want to build something, how we want to build it, and specifically what it is along the way that we want to build as well. So, what that looks like in practice is asking some sort of codified product manager role to help me draft a product requirements document, then asking for an architectural expert for a tech spec. And along the way, we are reviewing these requirement documents and these tech specs to validate that it does truly capture what it is we want to build. Then we're asking the model to generate a backlog of tasks to go after, step by step, a bit like we might use if we're interacting with the model in plan mode, combining both the context of the product requirements document and also the architecture document. And last but not least, we use an expert development agent to iterate through that backlog of tasks, step by step, one after the other, to go and build our rendering engine. And so on the right-hand side, you can see an example of a product requirements document that specifies explicitly each requirement that we have along the way, written in Markdown. And by writing these specs, it better tunes and hones the output of a model. This is what the spec-driven unicorn looked like along the way. The key detail captured along the way was an ask that we use Minecraft-inspired visuals and to also use some of the primitives that exist within Three.js as well. And so that yields much better results by grounding the model in a spec that codifies not only some kind of rendering requirements, but also giving it a little bit of steer that I might have as an engineer who's done some work in Three.js in the past. That actually it's quite hard to draw a unicorn, and if you think in simplistic visuals, it's going to perform much better. I will say there is not much of a market for 3D unicorn rendering engines in the world, but this just feels like a much more interesting and interactive way to explain the challenges of vibe coding and how spec-driven solves for it than yet another to-do app. The same is true for some sort of back-end administrative portal. The same concept applies by better specifying why you're building something and how you want to build it, along with what the requirements are. The outcomes are far better than with just one-shotting a prompt with a vibe-coded approach. So as we mentioned, spec-driven development brings much better predictability of outputs by grounding the model in specs and allowing models to produce much more deterministic results with fewer wasted cycles. It also solves for this over-eagerness or under-completeness. That's the scenario where we added a feature we didn't want or forgot about a requirement by grounding the model in a PRD with what it is that it actually has to build. Turns out that over-eagerness and under-completeness, two sort of prongs of the same problem, which is poorly defined requirements in the first place. We much better manage our context window with the model, and by having separate documents for product requirements, architecture requirements, and a story for our backlog, we're better managing the context we provide the model rather than trying to shoehorn it all into one prompt and wasting valuable tokens along the way. And we have less chance of busy work as well, where the model gets stuck and decides to arbitrarily retool with some other test runner, some other HTTP framework, some other front-end framework, because we've actually specified in our architecture document, here is the specific version of the specific frameworks that we want to use along the way. A very quick look at some of the building blocks of this. Typically what we'll do is combine some skills with some specs on a project level, like that requirements document, the PUD, some architecture specs. We'll also specify a bit of a constitution, sometimes called agents MD or cursor rules, where we specify some golden rules that we don't want the model to break. And then we'll also decompose all of the tasks into a backlog, which leads us to some story level specs as well. We'll also oftentimes make use of usage specs through tools like Tessel to be able to give the model better skills in interacting with frameworks' latest versions that might go past the knowledge cutoff of the model So things like the latest release of Fastify, the latest release of 3JS. The model doesn't know how to use these latest versions. It's beyond its knowledge cutoff. Usage specs can massively help there. So this is all well and good on greenfield projects, but does it work in brownfield, larger code bases? I've had some recent learnings from pretty small Django app, about 15,000 lines of code, but with no tests, no README. And what really helped here was using some of the brownfield detection modes in the spec-driven framework that I was using at the time. It was BMAD, to be able to document that existing code base. That yielded far better results than just trying to use agent mode in the IDE or vibe coding my way to a solution. And so by generating some specs for the existing repository, the model performed much better. So the big learning was documenting the project using an agent yielded really good results. I was also able to ingest a real-world PRD authored by humans rather than authored, in the loop of a spec-driven framework. And something I found that worked very well was the rigid framework of the Django system combined with its ORM for database connections made it very easy for the model to integrate new modules into the kind of established backend pattern that was there. Some of the places where gaps do still remain in the brownfield, there's lots of sort of tribal knowledge that exists on projects that, using a scan of the repository isn't going to capture. So that notion of, we never touch these lines of code because there be dragons, that's just not captured by documentation in the repository. That tribal knowledge still does matter in brownfield projects. There are some requirements that need to be hyper implicit for models to perform well. And so, if we've left out in our PRD that there needs to be a front end to access this functionality, the model won't author a front end. It will just write the back end, and that's going to be it. So there is some need to be a bit explicit. Agents can inherit bad anti-patterns within the code base. So, something to watch for. And then there is a pretty big context overhead as well. If you're not already, in the weeds of the brownfield project you're working in, it can be harder as an engineer. The context overload is pretty immense as humans as well as with models. It's hard to, it's still harder to operate in the brownfield where you don't know the code base. And so if we look at the outlook, what's really important, I think, is scaffolding tests ahead of beginning any sort of agentic work will pay dividends, be that UI automation testing, unit testing, whatever the methodology, but scaffolding testing before writing a line of code in the brownfield and getting to at least 80% test coverage will really help. The quality of the spec that you're coming with massively impacts the quality or the experience that you will have working in the brownfield. But it is a really nice complement to working in the greenfield to also be able to hone skills working in larger brownfield projects. Plenty of experience at Nearform working in much larger code bases with some of my colleagues as well in the brownfield when doing spec-driven development. I think one scenario was a 250,000 lines of code. So a proper, beefy enterprise code base. So it can work quite well, just requires some slightly different steps and approaches to working in the greenfield. How we scale this to work within the enterprise. It's funny, a lot of the challenges that exist scaling spec-driven development from an individual contributor to a team of contributors driving as humans, it's the same challenges as scaling, to work with with a swarm of agents as well. And that's been one of the learnings as we move to that stage 4. But we move from individual contributors driving stories in series to needing to be able to scale stories such that they can be worked in parallel. And so those tasks might split into front end and back end quite neatly. And being able to progress the backlog, the two backlogs in parallel becomes quite important. The other thing that becomes really important is merging and pushing frequently, deploying frequently, because the merge queue that builds up establishes much quicker when developing with the pace of agents than it does, with the pace of working just as humans on the code. And so merging and pushing, and of course, subsequently pulling the code frequently becomes all the more important. And so what does this kind of fourth frontier look like, the stage 4 of multi-agent orchestration? We sort of transition from the world of developers into the world of overseers. And so humans become more of a product manager than a typist, I suppose. And so we wind up, as developers authoring specs and designing features, and then throwing those specs at teams of agents to work the backlog in parallel. And that's the big shift from stages 1 through 3 to this fourth stage, that kind of frontier of orchestration, is that we are now driving agents in parallel, working in swarms to complete features. So there's a lot of trust encoded in that kind of workflow that the agents are operating against when you reach this level of maturity, and a huge amount of guardrail protection needed to ensure that what the model is built is well anchored in the specs, and a pretty sophisticated need for both an agentic review function, but then also a static analysis, be it using Sneak or SonarQube or whatever the tool set is, to cover both infosec needs and then also code quality needs to make sure that those match the needs of your team as well. The level of maturity needed to be able to orchestrate this much work becomes greater and greater. The other thing that happens is the bottleneck sort of flips. And the thing that limits your ability to move quickly is keeping the engine fed, keeping that swarm of agents fed with well decomposed specs, things that are well authored such that an agent can then execute on new features. And so the humans become the backlog, or the bottleneck rather. It becomes harder to keep moving at this pace when you're needing to align people on what it is that you want to build next. And that actually becomes the thing that ultimately slows down the work. What does one of these orchestration systems look like when you get to this kind of maturity? First of all, you have your work primitives. And so you have tasks, which lead to epics. Those kind of trackable delivery units wind up with kind of a hierarchy of work decomposed sensibly, such that it can be well parallelized, so that the front end list component that needs some header is not being developed in parallel. There's a natural ordering to front end work. Meanwhile, the back end work can be done in a separate agentic team, where the stubs for REST routes might first be built, and then the DB calls, and then the business logic. There is a sense to how the work is decomposed such that it is well split amongst the roles working in parallel. There's also a kind of a codification of specialized roles. So it's not 10 different agents that are identical, but instead we end up with specialized swarm workers for specializations like back-end engineering, front-end engineering, DevOps, and also agents that specialize in merging code, understanding the broader context, and figuring out how to sensibly resolve conflicts. And of course, there's also us, the human overseers of these systems as well. The work tends to have some method of writing to disk their context, such that when an agent session falls over, it can be rehydrated successfully and that work isn't lost, because that is a reality of working in parallel. Is oftentimes the session crashes, compaction happens, which harms the context window. And so being able to keep persistent state to disk using systems like beads become increasingly important. Backing that persistence layer with Git means there's a nice version log of what's happened over time. The other kind of important layer is a mailbox system, or an intercommunication system between these agents, being able to message and hand off that context from one worker to the other. So you wind up with this neat sort of symbiotic nervous system where all of the agents are collaborating together. Last but not least, graceful degradation becomes quite important. So being able to scale the system back from high degrees of parallelism to smaller degrees, depending on what stage of the development life cycle you're at, becomes increasingly important as well. And so what's the impact been beyond engineering of, this kind of fourth frontier? Because we've been seeing it actually play out in market as well. And I thought that was important to talk a little bit about. There's some great sort of thinking in Steve Yugi's blog posts, and there are some resources at the bottom of this slide that link to the source material here for these two. So there's some great material in the blogosphere around why this kind of matters and what the impacts will be beyond engineering. And so more, things to think about as leaders in the kind of product space, for how to build software that will survive. In particular, I wanted to talk about some of the traditional SaaS moats that are eroding and how some of these new moats are being established. So if we look at the learned interfaces of the likes of the Bloomberg terminal or Salesforce's SOCL, the Salesforce Object Query Language, things like SAP, that sort of learned interface over many years is no longer a viable moat when you can make use of an LLM to simply query that data using natural language. Similarly, codifying business logic becomes less defensible of a moat when you can simply capture business logic in Markdown and have something execute against that as a spec to codify the behavior that you want of a system very quickly. Things like access to data, making it easier to access data becomes less of a moat. And so businesses that have been built around SEC filings, case law, medical literature is no longer alone enough of a moat. And then also the scarcity of talent. When you can, as a domain expert, when you can now develop software systems at rapid pace, that is becoming less of a defensible moat. However, there are some new moats or kind of counterparts to these four things that I think may come to the fore. So if we look at, things like proprietary data, so things that can't be scraped, licensed, or synthesized easily, things like real-time S&P data, that becomes quite a defensible mode. It's hard to get into a position where you're able to access that data as a reseller easily. That's still a pretty defensible mode. Also, if we look at some of the kind of regulatory fortresses, things like HIPAA compliance, FDA audits, that type of compliance still is, very much a difficult barrier to entry or a difficult threshold to cross as a business. And so it becomes less about the technology, but more about the environment in which you do business in. Feels like that's still going to be around for many years to come as one of these sort of defensible moats. And the one I'm most interested in is this notion of insight compression. So being able to, now the data access is commoditized, being able to distill information, insights, or findings off the back of what might be public data is still quite valuable. So being able to, report on aggregations of data, and then derive insights off the back of that sort of, knowledge that is harder to gain or that relies on some form of domain expertise to compress into insights still feels like, a defensible moat. And the last one that we spend a lot of time thinking about, we're all familiar with user experience, UX, but thinking about AX, agent experience, in a world where, things like insight compression, that data that we might be compressing into valuable nuggets of wisdom, the way people are going to interact with this information is, very much changing from using a web browser to using a chat interface or indeed a voice interface. And so making information easy to access by agents becomes increasingly important. That may be as simple as adding an MCP connectivity layer for users who are subscribed to your information. But being able to optimize for agent experience becomes this increasingly important, almost table stakes now in the world of sort of engineering good product. And so if we look at a sort of a reference architecture for what all this looks like, we end up with a suite of tools that marries together, a lot of what we just talked about. And so, you come with an IDE that is enabled with MCP connectivity like Cursor, VS Code, or Cloud Code. That is connected via MCP to your suite of existing enterprise tools like Teams, Slack, Confluence, Jira, backlogs of security issues that might exist in Sneak, code issues in SonarQube, designs that might live in Figma, automating the browser through Playwright to be able to generate tests, doing DevOps work off the back of a connection into AWS or indeed Azure over MCP. And so your MCP enabled IDE is now able to access all of this context and information that exists in these tools, but also your foundation models, your baseline chat interface that you're using in the rest of your business using ChatGPT or Claude is also able to integrate with these tools. And so you end up with a very rich and integrated ecosystem. If we double click on the sort of MCP enabled world of IDEs, then, we wind up with a couple of building blocks in there. And Cloud Code tends to be the sort of market leader that codifies the primitives in this space. But we end up with agent skills, sort of specializations that the agent has in their day-to-day coding work in the space of things like DevOps, being a senior developer, doing QA, and so on. We also wind up with a spec-driven framework to help context engineer our way to success in the likes of BMAD or OpenSpec, and indeed choosing an IDE that has spec-driven development as a first-class principle can also help here with the likes of Anti-Gravity or Kiro. Then, as we reach that stage 4 level of maturity, we wind up with an agent orchestration platform like Cloud Code Teams, along with kind of usage specs along the way as well, and registries of skills that we can run eval suites against with the likes of Tessel. And so what does the future hold for this space? I mean, the kind of key takeaways, first of all, are that some of these traditional SaaS moats are very much dissolving. And so we need to start thinking about new ways of building products to exist in the era of agents in order to build successful businesses ultimately. The hyperparameter race doesn't feel like the kind of future, the immediate future of new developments in the world of coding. And in fact, frameworks that help context engineer and orchestrate agents is the next big unlock for most businesses, not newer and increasingly capable models. Orchestration feels like the next wave of kind of maturity in the world of AI enabled development. And lastly, a lot of the kind of spec driven frameworks and orchestration will become first class primitives in IDEs over time. Only within the last sort of 10 days, Claude Code enabled teams to collaborate and swarm as agents. And we'll see increasingly that spec driven concepts get codified like they have been into Kiro, into other IDEs. Similarly, orchestration feels like the next frontier to being embedded into user interfaces. Right now, the only way to orchestrate agents is by using tmux, which is kind of hard for most users. That will get more and more user friendly. And so if folks are looking to go further with sort of AI native development and the four stages of maturity, a great place to start is by just reading. Either Martin Fowler's blog has some great material on spec-driven development and the frameworks that exist. Also worth very much reading, worth downloading Amazon's Kiro, a great way to get started both with vibe coding, but then more importantly with spec-driven development, since it's there as a primitive in the user interface. And as you level up, start learning how Anthropic are working at scale with Boris Cherny's series of posts on X about working with parallel agents, plan mode, sub-agents, all that good stuff. Worth checking out the BMAD method, as kind of spec-driven development matures. Also worth evaluating if you feel like you're pretty mature in your context engineering, things like OpenSpec. And then if you're interested in learning what's happening at the frontiers, Steve Yiggy's blog posts are probably the best point to begin that journey. So what does the sort of presently unhinged but future going to be a kind of a utopia world of multi-agent orchestration look like? And what does that mean for the future of businesses as well? Thanks so much for your time today. I've been Cian Clarke. I'm Nearform's head of AI. And if you're interested in learning a little bit more about the world of spec-driven development, agent orchestration, and how to apply this at scale in the enterprise, we'd love to hear. We organize pretty regularly sessions with companies, talking through this maturity journey and plotting their kind of path to sort of getting more progressive in their use of AI across the enterprise, and then also being more productive as an engineering org in using some of these AI native tools. So we would love to hear from you. Thanks so much.